This video is going to demonstrate how to graph exponential functions, whether it's an exponential growth or an exponential decay. Now, a couple things to keep in mind is first thing you want to do is identify any asymptotes, which are boundary lines that restricts the graph. And in this case, um, you're not going to have a vertical asymptote line. You're going to have a horizontal asymptote line. And many of these, it's going to be the x-axis. The y-value cannot be a negative number because we're not dealing with any negative bases here or anything like that. So the y-value is always going to be above 0. So f of x equaling 4 raised to the x power, my horizontal asymptote, so HA, is going to be y is greater than 0. So if I want to identify that on my graph, it's just going to be a horizontal dashed line across my x-axis. And then I'm going to choose some y value or x values to plug into this function to find a y value. Now you can choose any x coordinates that you want. I would highly suggest using three of the easiest numbers that you can use that you don't even have to use your calculator for. Be very quick to plot these 3 points and draw a general exponential function. So the three x values that I normally choose would be -1, 0, and 1. Now if I put a -1 in for x, 4 to the negative first power, anytime you have a base raised to a negative exponent, you have to write the reciprocal of the base. So the reciprocal of 4 is 1/4, and then I raise it to the first power, which will give us 1/4. So I would have -1, and then my y value would be 1/4. If I put 4 to the 0 power, any time I raise a base to a 0 power, it's always going to equal 1. So that would be 0, 1. And then 4 to the first power, anything to the power of 1 is itself, or it's a base. So this will give us 4. So now I have three points that I can plot on the graph here. So I have -1 and then 1/4. -1 and then 1/4 would be roughly here. And then I have 0, 1, which would be here. And then I have 1 and then 4, which would be up here. Now if I want to make these a different color so we can see our points a little bit better, and then I'll use a blue line so it goes close to the x-axis but doesn't touch it or cross it, and then it jumps up rapidly here. So that is an example of an exponential growth. Again, I knew it's a growth because our base is bigger than 1. Another example, here we're going to do the same thing, identify any asymptotes. Again, the asymptote line is going to be a horizontal asymptote where y is going to be greater than 0. Going to choose some x values. Again, I'm going to just choose the same x values that I did before. I'm going to use -1, 0, and 1. So if I have 1/2 raised to the negative first power, that means I have to take the reciprocal of the base. The base is half. The reciprocal of half is 2. Raise that to the first power, which will give us 2. 1/2 to the 0 power is 1. And then 1/2 to the first power is itself, so that's 1/2. So now to graph that, let's put it in our horizontal asymptote line. So I'm just going to draw that down here. So we have -1 and 2. We got 0, 1. And we got 1 and then half. And then we can draw our line here. Now, if I wanted to raise this to the second power, 1/2 to the second power is 1/4. 1/2 to the third power would be 1/8. You see it's getting smaller and smaller, but you can never raise a base to a power where it's going to give you a value of 0 or below. So that would be our example of an exponential decay function. So that is how you can graph exponential functions on a coordinate plane.